Hello everyone, welcome to the 8th video tutorial for Intel Galileo Gen 1 development board. In the 7th video, we saw some basic examples of using GPIO, ADC and I2C interfaces available on Galileo. In this video, we will create an example demo to capture an image from a webcam connected to Galileo via USB. In the second part of this video tutorial, we will also see how to translate a text to a destination language using Google Translate API via Galileo. We will also create a demo for using Google Text-to-Speech Translate API via Galileo. In the third part of this video tutorial, we will create a simple example to demonstrate how to use an Adafruit 2.8-inch TFT LCD screen using an Arduino sketch. Let us start the first part of this video tutorial to capture an image from webcam connected via USB. Galileo Gen 1 provides a micro USB for USB host connections. So, we will need a mini to micro USB converter in order to connect USB webcams having mini USB cable. When I connect this USB webcam to Galileo, we see on the console that USB device has been registered. Now when I type LSUSB, we can see Logitech webcam device ID. Let us now write an OpenCV C++ code to capture an image through webcam. Let us open a file named capture_img.cpp. If the Python OpenCV is not installed, we can install it by obtaining the IPK from the link given on the screen. I have already installed Python OpenCV here. We will include the Python OpenCV header file. Next, we will create a pointer to the camera device. Since we only have one webcam attached to Galileo, we will use device number 0. And thus, we will write CV create camera capture 0. If we had more than one camera attached to Galileo and we wish to use specific camera device for our application, corresponding cam device number should be inserted in the round brackets. Next, we will give out an error if the capture was unsuccessful. Else, we will capture a frame and save it as an image file. We will then release the captured frame and close the main function. Now we will save and close the file. Next, we will compile the C++ code using G++. We will type G++ pkg-config libs opencv capture_img.cpp and the output as capture_img_o. We might get an error regarding OpenCV. For the time being, we will open the file /usr/lib/pkg-config/opencv.pc, search for opencv_ts and delete it. We will again try to compile the code and this time it compiled successfully. Then we will run the capture_img_o file. You can see an image file is created. Next, to view this image file, I will transfer the image to my PC and view it there. To send the file to PC, we will use SFTP, that is Secure File Transfer Protocol. To use SFTP on Windows, we will download PSFTP from the given link on the screen. Once downloaded, we will open the application and type open followed by the IP address of Galileo. We will type yes followed by logging in. Next, we will mainly use two commands to communicate with Galileo from our PC for the file transfers. Put command is used to transfer file from PC to Galileo. Similarly, get command is used to transfer file from Galileo to PC. Here I will use get followed by the path of image file from root. Unless a specific destination path is given, the files are transferred to the folder from where PSFTP is run by default. So, when I now open the image file, we can see a clicked picture. With few cameras, there can be sometimes a frame bandwidth issue. This issue can be solved by adding 3 lines shown on the screen. Before the line in the code, CV query frame. The image produced will be too small as seen by the frame width and frame height, but image would be complete. You can also try setting different frame size parameters. Alternatively, Galileo Yocto provides an application called FS Webcam. We can install FS Webcam by typing wget followed by opkg install FS Webcam IPK file. Then we will type FS Webcam followed by the name of image file we wish. We can follow same steps to transfer the file to PC and view it. In the second part of this video tutorial, we will use two Google APIs. One is Google Translate and the other is Google Text-to-Speech Converter. We will make sure Galileo is connected to internet via LAN or Wi-Fi. In this video, we will connect Galileo via LAN and check if it is connected to internet by typing ifconfig on the shell and verifying IP address. Let us convert the word study from English to German. The code for English is EN and the code for German is DE. We will use curl to access Google Translate and obtain translated text. We will follow the command syntax as shown on the screen. For more details on options using curl, we can type curl --help on the shell. Next, from the HTML file obtained after translation, we will grab the encoding technique used for translation using awk and sed. Next, we will grab the text of interest from the HTML file recognized by the encoding technique. Yocto provides application known as iconv, which is used to convert to one of the character encoded text. We will also convert this HTML encoded to a UTF-8 character encoded format. In order to convert the HTML to text, we will have to install HTML to text application. To download and install this application, please follow the steps given on the screen. The installation will take a few minutes. Now when I type the earlier command and hit enter, we can see word study printed in German on the console. Next, we will try to translate and convert the text to a destination language using Google Text-to-Speech Translate API. To demonstrate this, we will use wget to download a MP3 format of the translated text. In the query search, we will type the destination language code followed by the text to be translated. The command is as shown on the screen. The output.mp3 is an encoded format not recognized by many media players available on Galileo. So we will use an application named lame to convert this mp3 format to a .wav format. To download and install lame, please follow the steps given on the screen. Installation will take few minutes. Then we will use lame to convert .mp3 file to a .wav file. Galileo Yocto Image provides ELSA Player, which is advanced Linux sound architecture that plays .wav format. We will use a pair of earphones which can be connected to Galileo using a USB sound card as shown in the screen. When I now type aplay followed by the .wav file, we can hear the translated text on the earphones. In the third part of this video tutorial, we will demonstrate a small example using Adafruit TFT LCD screen with Galileo through an Arduino sketch. We will place the TFT screen on Galileo Shield interface. Next, we will open Arduino application. Before opening the application, we will download 3 additional Arduino libraries in order to get the TFT LCD screen working. The libraries are available on GitHub by Kurt E. and Wallace Q. The link to the download libraries are given on the screen. Once we download these libraries, we will extract these libraries to the libraries folder in the Arduino folder in our system. We will make sure that the folder names are Adafruit_GFX, Adafruit_ILI 9341 and Adafruit_STMPE610. Now we will restart Arduino. In the file examples under the Adafruit_ILI 93413, we will open the graphics test example. We will compile and upload the sketch to Galileo and see the output on the screen. Next, to demonstrate the TFT screen with Arduino on Galileo, we will open Touch Test Sketch from File, Examples, Adafruit STMP610 directory. We will use hardware SPI, and thus we will comment line number 27 and uncomment line number 35. We will pass the argument 8 to this function as the CS pin on Galileo is available at pin 8. Next, we will hit compile and upload sketch to Galileo. The blue and green colors on the screen are because I did not let the first graphics test to complete and uploaded a new sketch. Now, we will open the serial monitor, and when I touch the screen, I can see the XYZ coordinates on the serial monitor, with Z being the pressure applied on the screen. So this ends the basic demos to capture an image from webcam, use Google Translate APIs, and use an Adafruit TFT LCD screen via Arduino Sketch. Thank you for watching this video. I hope you enjoyed it.